Welcome to Spring LIB.
Okay, so we're doing chapter 23, problem 61. So it says an electron starting from rest acquires a kinetic energy of 1.33 kiloelectron volts from point A to point B. So part A says how much kinetic energy would a proton acquire starting from at rest at point B and moving to A. So this is B to A. Okay, so the change in potential energy equals the negative change in kinetic here, and the change in potential is equal to the charge times the change in voltage. Okay, so basically the only thing we're changing now is from Q being positive to Q being negative. But we're also going from B to point A. And if you travel one way from a potential of point A to B, that means if you have a positive charge, this is going from high potential to low potential. If you have a negative charge, it's the other way around. But if we flip the charge and flip the direction we're going, they cancel each other out at the same time. So that means we actually have the exact same kinetic energy gained because the change in potential energy is the same. And if the change in potential energy is the same, that means the kinetic energy change is also going to be the same. So still 1.33 kiloelectron volts. Part B, determine the ratio of their speeds at the end of their respective trajectories. Okay, they both gain the same kinetic energy, so we can set the kinetic energy equal to each other at the final, but they don't have the same mass, right? So if we simplify this, and we simplify this to try to find out what VE over VP is. So let's solve that. So VE squared over VP squared should be 1/2 MP over 1/2 ME. So if we put this in here and square root it, we should have this being the square root of MP over ME. So that becomes mass of a proton is 1.67 times 10 to the negative 27 kilograms. Mass of the electron is 9.11 times 10 to the negative 31 kilograms. If we plug that in our calculator, we see that the ratio in their speeds is roughly 42.8. Let me write that better. 42.8. Meaning the electron is 42.8 times quicker at the end of this than the proton.